video, we're going to introduce functions. First, the vocabulary. A function consists of a set called the domain containing numbers called inputs and a set called the range containing numbers called outputs. The domain is a set of all inputs of a function. The range is a set of all outputs of a function. The independent variable is the input variable of a function. The dependent variable is the output variable of a function. And the vertical line test, a graph relation is a function if there is no vertical lines that intersect the graph relation in more than one point. Example 1, determine if the following is a function. Explain why or why not. And identify the domain and range. Let's look at part A. We have x is 1, 2, 1, 3, 4, and let's take a really close look at this 1. So we're saying 1 goes to 4 and 1 goes to 2, which is not allowed. So we can't have repeating values of x going to two separate values of y. So this is not a function. And we can do our domain. Our domain would just be 1, 2. We don't have to write to repeat it 1, 3, and 4. And our range would be 2, 3, 4, 5, and 6. And we're done part A. Part B, we have 0, 1, 2, 3, 4, 5. So this is a function. And we can write our domain as 0, 1, 2, 3, and 4. And we're using curly brackets, by the way, and we'll use R for our range. And then we just write 1, 2, 3, 4, and 5, and we are done. For part C, we have -2, -1, 0, 1, and 2. We have 4, 1, 0, 1, 4. We don't have any repeated x values, so this is a function. Our domain, we can write down as -2, -1, 0, 1, and 2. And our range is 4, 1, and 0. And we are done example 1. Example 2, determine the following as a function. So in example part, and identify the domain and range. So in part A, we have a mapping. So we have A going to X, B going to Y, and C going to Z. So this is a function. Our domain is the part in part A. So it's the parts that's being used, the A, B, and C. And our range will be just X, Y, and Z. And we're done. Part B, we have 1 going to A and B, 2 going to C, 3 going to C, and 4 going to C. Because 1's going to A and B, this is not a function. We write our domain as the set in part A. The first set will be 1, 2, 3, 4. And our range is just A, B, and C. Part C, we're given several ordered pairs. So you have 2 and 0, 4 and 1, 2.1 and 4, 1 and 4, 4 and -1. We have a problem with the 4, so I'll highlight that. So if we see 4, -1, 4, -1, it's going to the same point. So this is a so whenever you see a repeated value, you always want to double check and make sure it's the same point. If it's the same point, it is a function. If it's not the same point, it is not a function. So this is a function. So our domain is just our x value. So we have 2, 4, 2.1, and 1. The 4 is repeated, so we have to write that a second time. And we have a range of 0, -1, 4, 4 is repeated, and -1 is repeated. So there's our range, and we're done part C. For C, D, we have 2 and 1, 4 and 0, 2.1 and 1, 1 and 0, and 5 and 1. So we don't have any repeated x values. So this is a function. Our domain will be the x coordinates of our ordered pair. So that'd be just 2, 4, 2.1, 1, and 5. Our range will be 1 and 0, 1, 0, and 1. So it's just 1 and 0, and we are done this example. Example 3. Determine if the following is a function. Explain why or why not. So we have this graph to the left, and when we have a graph, we use what's called the vertical line test. So what we do, we just drop a vertical line anywhere in the graph, and we'll do it at 4 after I dropped it at 6, 8, anywhere I wanted to. And I'm touching at 2 points, no matter where I drop. So if it touches the 2 points, for part A, we say it's not a function. And the reason being, it fails the vertical line test. For part B, identify the domain and the range. So our domain, it looks like we start at 1. So it would be just from square bracket 1 to infinity. And then our range would just be negative infinity to positive infinity, because it looks like we keep going down. We can keep on going farther and farther down and farther up. So negative infinity to positive infinity. Determine f of 1. F of 1 is this point right here. So f of 1 equals 0. And then at f of 2, it looks like we have 2 values. So f of 2 equals 1, and we have 1. So that also convinces us that this is not a function, because we have a function having 2 values, which we know is not allowed. And D, f x equals 2 when x equals, so we need to figure out what the x value is. So at 2, looks like it's about here. So that will be 5. So f of x equals 2 when x is 5, and we on this problem.